Hope you guys had a good lunch. Today we are going to cover divide and conquer merge sorts. So, what is the divide and conquer algorithm? Well, essentially, it's kind of in the name, right? So, merge sort is a divide and conquer sorting method, which it does as the name states. It takes an unorganized array and breaks it down to its lowest level, right? And it works up backwards as it sorts sublist of itself. In a sense, itself it breaks itself in half over and over again until it reaches a list of multiple sublists that hold only one value. Once it reaches its lowest level, it works its way back up, comparing its sublists against each other and merging them into a single sorted list. And we kind of see how that is kind of broken up into. Here we have the initial list we'll be working with today. It is an unorganized list of integers. The concept of divide and conquer is to break up our problem into subproblems. So we see this list here. It is broken off in half, which makes it into two sublists. And then we break it off even further as we go through the divide method part of the application. So these two sublists get created into something even smaller. On both ends. And this might be a little slow, but for the sake of showing you guys what's happening and the request of TL Draw, I have listened to the masses. Right? So these two sublists essentially end up being even smaller. And then finally leading us to what it will look like at the end, giving us essentially a form of a binary tree, right? Where we break off the individual lists into smaller sections of itself. All right. And then from here, what happens afterwards is the actual sorting of the algorithm. So we went through the divide portion of it, and then we go through the conquering portion of our actual algorithm, where we grab the individual sublists, and then we compare which one is greater or less than the other. When we compare these two, 2 ends up being less than 8. We have 3 less than 5. 4 less than 9. And finally, 1 less than 7. So we rejoin them into sorted lists. Once we get to this step, we do another comparison. And in a sense, we almost create like pointers where we can track the different index of what we are working on and create another list where we compare those indexes. So essentially, we will have some kind of pointer on the left and some pointer on the right. The first one might be on 2, the other one on 3. It will say which one is less than the other one. Well, 2 ends up being less, so we attach 2 here. This leaves us with 8 here, 3 and 5 here. We check the comparison of 8 and 3. 3 is less, so it gets added here. Leaves us with 8 and 5. We check 8 and 5. we add 5, and then finally we add 8. And we do the exact same thing on this end, where it ends up returning to us 1, 4, 7, and 9. And finally, to finish it off, we compare the last sublists against each other. Once again, 2 pointers, one on the left, one on the right, where we compare 2 and 1. 1 obviously wins, and it ends up returning our sorted list. Do I have any questions on the concept of how the divide and conquer method works? Big scope concept-wise. All right. Now, to get into some code, we are going to define 2 different methods. One method will be the merge sort itself, the overall problem. And then we will create a helper function, which we'll call merge, which will do the actual sorting of our sublists. So we can define merge sort. And this is going to take items. And items are essentially going to be a formatted, I'm sorry, not a formatted, an unorganized list. So just like we saw here, we will receive some kind of input like this, where it's going to be an unorganized list of integers.
When you get a chance, can you zoom in on your VS Code?
Yes, I can. There we go. Is that okay, James? All right. So we create our merge sort. And one of the first things that we are going to need to do is grab the length of our items, which will allow us to keep track of the overall sorting of how long or how far we have to actually sort through when it comes to the range. So we'll say items length is equal to length of items. Find the length of our list to track our loop. After we identify how big our list is, I would check if the items list that is being handed to us is less than or equal to 1. And in the event that it is, we might as well just return it as is, because it will be already sorted if it's empty or there's only one item in there. So we can say if items length is less than or equal to 1, then I want to return items. Right? We are checking if the list has 1 or less items. If so, return list, because it is sorted. All right. Next is we have to do the dividing in the divide and conquer method. All right. We can do this by building our sublist from bottom up, essentially breaking each item in the list into its own sublist of length of 1. And then we are going to combine them into sublists of length 2, and then sort them, and then combine them into sublists of length 4, and then sort them, and so on. All right, to start, we are going to declare a variable and call it sublist length, and we're going to assign it 1. And this will help us track the size of our sublists in our merge sort as we loop through our list. As we mentioned within the explanation, we want to break it down to its smallest component, which essentially will end up being a list of size 1, right? Where each little sublist only has one item to represent this output right here. We're going to create a while loop, and this while loop will be the outer loop that can help us keep track of the looping until our list is sorted. So we will say while sublist length is less than items length, right? So this is checking how big our sublists are. Well, eventually, if the sublist is equal to the size of our original list, then that means our sublists have been merged to a point where they're finally back together to its original state. Therefore, we no longer have to sort. This will be our outer loop to keep track of that process. Next, we're going to run a for loop, and we're going to start it at index 0, and it will run up to the length of the item's length. And we're going to step twice by multiplying the sublist length by 1. I'm sorry, by 2. So it'll look something like this, where I say for I in range of 0. So I'm going to start at 0. I want to go up to the length of whatever items is. So in this scenario, I believe, what was it? Give me a second. Let me get us our data. Our data is going to look something like this. We can just leave it like that for now. The item list will be 2, 3, 4, 5, 6, 7, 8, right? So for I in range of 0 to 8, and then the third argument within the range method is called step. We are going to do 2 times sublist length, right? What that does is that as it's looping through, it's not going to go in order of 0, 1, 2, 3, 4, so on and so forth. It's going to take the length of our sublist, multiply that by 2, and then we're going to skip that many. Right? That's going to help us keep track of the fact that our sublist is going to get bigger every single time. Therefore, the way that we do our for I in range needs to change. Do I have any questions so far of anything that we have coded so far? All right. So once we have that, we are going to say left sublist is equal to, and then we can talk about this in a bit, and then right sublist is equal to. Right, we are essentially going to create 2 different variables, and these variables are going to be lists of whatever our sublist that we are currently working on. So at the beginning, our first sublist should be something like this, where left is equal to 2 and right is equal to 8. Right? So the way that we are going to grab that is by saying items, right? We're calling the actual list. And then we are going to slice this list starting at index I, which is going to be at the very start, it's going to be 0. It's going to go up to I plus the sublist length, right? So 0 up to 0 plus sublist length. Well, what's sublist length? It's 1. So the first time this iterates, it's going to be 0, 1. So this should look like items 0, 1. And then for our right sublist, we are going to say items I plus sublist length for the start of our slice. And then the right is going to be I plus 2 times sublist length. So the first time this runs, this show something like items I is 0 plus sublist length is 1. So this brings this to 1. And then once again, this is 0. 2 times 1 is 2. Therefore, making this 2. Right, 0 plus 2. So the first time this loops, this grabs from 0 to 1, therefore grabbing 2. And this is going to start at index 1 up to, but not including index 2, therefore grabbing 8. All right, so this first time this runs, left sublist is equal to 2, and right sublist is equal to 8. Once we have our left and our right sublist, we're going to want to actually do some form of sorting. Now, as I mentioned to you guys before, we are going to use a helper function. It should be something like this, where it says merge sublists is equal to my helper function. And then I would add left sublist in here and right sublist. But we have to define this. So at the very bottom, I'm going to say define merge. I'm going to take in left, and I'm going to take in right. This merge function is going to contain two sublists, right? Left and right, that we will pit against each other to see how they should be sorted. At the very end of this, we need to create some form of variable that we can use to store the current sort of it, if that makes sense. I hear Mike. Does anyone have any questions? Okay. This result variable is going to be where I'm going to store my essentially sorted list, right? We mentioned making some pointers. So I'm going to say ij is equal to 0, 0. This is going to be my left and right pointers that I will utilize to sort my lists. Right. To talk about where I'm at right now, we created our sublists. We grabbed a left and a right list, right? Right now we're working on 2 and 8. We passed it to a method called merge, and then we are going to sort these. Right now we can start a while loop within this merge. We're going to say while I is less than the length of left and j less than the length of right, I want to do the following. What this is showing is in the event that we have, let's say we said 2 and 8, we are going to check these two numbers, and then we're going to identify which one is less than the other one. Well, in this scenario, 2 is obviously going to be lower than 8. So what we should do is add it to our results, and then we are going to essentially remove what's here. Or if not remove, we're going to move our pointer, right? So I will be increased by 1. Therefore, it won't be pointing at 2 anymore. And it's going to fail this check where I is less than the length of whatever this list is. So it will stop sorting that part. Still with me? If this was like 2, 5, or 6, whatever, the first time this runs, it'll check 2 and 8. We'll add 2 to results. We move index I to 1, so we increase its count. So it's now pointing at 2. Right, and then we compare 6 and then 8. We check 6 and 8, which one is less? 6 wins, so we add 6 in there. The I will end up being the same as the length of whatever left is. So this will stop. And then we'll talk about how we will do the rest. Let's remove this. From here, we are going to say if left I is less than right J, then we should add left I into result and then move our I. So we'll say result dot append left I. And then I plus equals 1, therefore shifting our left pointer to the right. Now, if that doesn't happen, then that means that right is greater than left. So we should say result dot append right index J, and then we increase J by 1. Right? At a certain point, when it sorts 2, 2 gets added, index 1, right? Index I, I'm sorry, I misspoke. Index I is no longer within range of what left has. So this will no longer go, but we still have another number that has not been sorted yet. So outside this while loop, once we no longer meet this condition, we're going to say while I is less than length of left, result dot append left I plus equals 1, and we're gonna do the exact same thing for J. While J is less than the length of right, result dot append right J. J plus equals 1. So, as mentioned before in the scenario, index I gets increased by 1, therefore making it 1 from 0 to 1. So this no longer meets this criteria. So we now move down to these 2 while loops. It checks while I is less than the length of left. Well, it won't pass this check because we've already
Hello?
came to.
Hey,
Hello,
What's up?
Len, your
what's going on?
mic.
Too much?
There you go. Sorry, hot mic. So it won't pass this constraint because we've already established that I is now the index of 1, therefore out of range. So it goes to here and it's gonna check while J is less than the length of right, which is still true. We never increased right. So it's going to keep running this until it appends everything in the list, bringing this to 8. Well, you might ask yourself, well, Roger, what happens if there's more than just one number? Like, are they sorted? Yes, right? Going back to the concept of divide and conquer, every time that list gets bigger, those lists are already sorted. We are sorting the left and the right and pitting them against each other, right? So what happens here is we will also check these at some point, right? But this will return like this. These 2 will be sorted. So if I run this, what's going to happen? Okay, let's move this. The second time this runs and our sublist increase, we have something like left is equal to 2 and 8, right? We ran the first loop, it sorted those. Now we have a much bigger sublist where this is 3 and 5. It's going to check index 0 and index 0 for right as well, because that's what we established. It's going to say, hey, is I less than j? It is, therefore 2 gets added in here. I increases to 1, so now it's pointing at 8. But j is still at 3. It's going to say, which one's bigger, I or j? Well, j is smaller, I is bigger because I is pointing at 8. So j will be added in here. J gets increased. Now we're looking at both of these. 5 is less than 8, so 5 gets added. And then 8 gets added. In the event one of these ends up having 2 numbers, and this has already been exhausted, we made it all the way through one of these sublists. Remember, these are still sorted. As we're getting bigger, we're comparing sorted lists amongst each other to see if the left is sorted to the right. So this will work. Let's go ahead and empty this out. Now we can go ahead and bring it back up. We have our merge sublist. It takes in the sublists that are passed in within this function. It sorts them. And once they are sorted, the next step is to add it to our original list to make sure that we have the sorted part of it. And that's going to look like this, where we say items. We're going to call the original list. We're going to get index I, which in this event, this is returning 2 and 8 after they've been sorted. Right? What is this while loop still at? Or this for I in range? It starts at 0, right? We're still at 0. So this is 0. And the right side is going to be I plus the length of merge lists, merge sublists. And that is equal to merge sublist. Well, what is this saying? This is saying items from index 0 to whatever the length of our merge sublist. Well, it's 2. Everything from index 0 up to index 2 is now equal to the merge version of our sublist. Right? Therefore, this for I in range, the first iteration, is now complete. The next step is saying sublist length, multiply that by 2. What is sublist length right now? It is 1. So we multiply that by 2. So this now becomes 2. It goes back into the for loop, and it says for I in range of 0 up to 8, I believe. And I want to skip from 2 times the sublist being 4. So it's going to skip the next 4, right? So as it's doing this, it's taking into account that our sublist has increased. Therefore, what we grab now changes. At the very end, once sublist reaches the size of what our items list is, we can return items. And then finally, we can go ahead and run this and say sorted is equal to merge sorts. We pass in the data that we have above, and let's print out sorted. Python merge sort.py. It does not like none type of length. Merge sublist. It is not liking something. Why is there nothing in here? Am I not passing it in? We didn't return anything, did we? There we go. That's what it was. My bad. Right here. We never returned anything after the merge function is ran. We have to return results. Right? We sorted a list, but we never returned it to have the merge sort to have access to it. Once again, let's run it. And we see 1, 2, 3, 4, 5, 7, 8, and 9. It successfully sorted our list. Do I have any questions on the divide and conquer method, merge sort, or any of the code? Yes, James.
Could you go down to the merge function again? Can you re-explain? I almost think I understand, like there's 3 different while loops, and I almost don't see the point of the first one if you have the last 2. What's the point of doing the while and for the first one compared to the final 2?
Yeah, well, it's going to depend on what your sublists that you are comparing are. In this situation, they were successfully merged with nothing big left over, right? But in the event, let's say that all the first parts of the list were on the left side and left made it all the way to the end before right moved, then we need to add all of right into our results, right? Because right has yet to move. We have yet to add that within our result value here. So let me come down here and it gets to this part here and it says while J is less than the length of right, and which it is true because we never increased the right pointer because everything that was on the left side was less than on the right. Therefore, right never moves. So we still have to add everything from the right sublist into our results.
Got it. Okay, that makes more sense now. Yeah, thank you.
No problem. Any other questions, guys? All right, let me just check something real quick. In the curriculum, you can find a video that will explain to you exactly what I explained to you guys with the imagery. I'm sorry, I got ads. They'll come down here and they can show you as well how the merge sort works. And also, I believe Adam was the one that created this. He has a more detailed version of the TL draw if you would like something different than what I drew. But it shows you the comparisons as well. All right, the divide portion and then the actual conquering of tackling the sorting of it. All right. The time complexity of this is O n log of n. If you guys were wondering about the time complexity, it's not the most efficient, I will say, but you do have the time complexity here if you guys were curious. But if I have no further questions, I'm gonna go ahead and stop the recording now.